Across the planet, engineers have built structures in places once considered impossible to reach. From towering mountains to deep valleys, these structures push engineering beyond its traditional limits. Every massive project begins with one challenge. How can humans safely build against nature? Engineers combine advanced machines, precise planning, and enormous structures to overcome these extreme environments. But behind every breathtaking structure lies a story of risk, innovation, and extraordinary human determination. Some roads are built directly into mountains, where one mistake can mean a catastrophic fall. Deep inside solid rock, massive tunnel boring machines slowly carve pathways through mountains. Engineers use powerful drilling equipment to remove enormous quantities of rock with remarkable precision. On near vertical cliffs, specialized crews anchor massive structures directly into the mountain itself. Once complete, these extreme routes transform dangerous terrain into vital connections between communities. Suspension bridges can span enormous gorges, carrying people and vehicles hundreds of meters above the ground. Construction begins with foundations engineered to transfer the bridge's enormous loads deep into solid bedrock. Tower by tower, massive structural sections are lifted and assembled high above the surrounding landscape. Thousands of steel wires are combined to create powerful cables capable of supporting immense forces. Finally, enormous deck sections are positioned with millimeter-level precision, connecting the two sides. The final bridge section must align perfectly, creating one continuous structure across the enormous gap. Before opening, engineers use controlled load tests to verify the bridge can safely handle heavy traffic. Advanced monitoring systems help engineers understand how the structure responds to powerful winds and other forces. Once operational, these bridges dramatically shorten journeys and connect previously isolated regions. What once seemed impossible becomes a vital transportation link and a remarkable monument to engineering. Some bridges stretch for kilometers across open ocean, carrying traffic where only water once separated communities. Building in deep water requires massive platforms, specialized cranes, and foundations engineered beneath the waves. Deep underwater, enormous foundations are anchored into the seabed to support the bridge above. Engineers must battle powerful waves, strong winds, changing tides, and unpredictable marine conditions. When completed, these bridges connect cities, accelerate trade, and transform regional transportation networks. Some of the most extraordinary engineering projects disappear beneath mountains, turning solid rock into transportation corridors. At the heart of these projects, gigantic tunnel boring machines slowly grind through mountains, meter by meter. Conveyor systems then carry millions of tons of excavated rock away from the underground construction zone. After excavation, workers reinforce the raw tunnel with steel supports, rock bolts, and layers of sprayed concrete. When finished, the once dark passage becomes a safe, illuminated route through the heart of the mountain. Even the ocean can be crossed from below, with tunnels extending deep beneath the seabed. Powerful tunnel boring machines excavate beneath the ocean floor, while engineers carefully control underground pressure. Specialized waterproofing and concrete segments protect these tunnels from the enormous pressure of surrounding water. Ventilation, drainage, emergency systems, and continuous monitoring keep travelers safe deep underground. These undersea tunnels connect regions once separated by water, dramatically improving transportation and trade. Massive dams stand like concrete mountains, holding back billions of tons of water behind their walls. Before construction begins, engineers divert the river so the enormous dam foundation can be built safely. Layer after layer, millions of tons of concrete are placed, compacted, and carefully inspected. Spillways control excess water, protecting the dam and surrounding communities during extreme floods. Inside the dam complex, enormous turbines convert flowing water into electricity for entire regions. Far offshore, Enormous engineering structures rise from the ocean, built far from any coastline. Their foundations extend deep beneath the waves, anchored into the seabed to withstand enormous forces. Specialized heavy-lift cranes carefully position massive steel components weighing hundreds or even thousands of tons. These structures must survive powerful waves, extreme winds, salt water, and constantly changing ocean conditions. Offshore infrastructure connects distant resources, transportation networks, and industries to the world economy. Some structures rise hundreds of meters above the city, transforming limited urban space into vertical worlds. Super-tall skyscrapers are built floor by floor using tower cranes, reinforced concrete, and massive structural systems. Far below the skyline, deep foundations anchor these enormous towers securely into the ground. Special dampers and flexible structural systems help skyscrapers withstand powerful winds and constant movement. Above the clouds, these towers provide homes, offices, and commercial space within incredibly dense cities. Some extraordinary structures cling directly to cliffs, occupying spaces where conventional construction seems impossible. Engineers drill deep into solid rock, installing powerful anchors that transfer structural forces into the mountain. High above the ground, specialized crews assemble steel platforms while secured against extreme heights and strong winds. Drainage channels, retaining walls, and rockfall barriers protect these structures from nature's unpredictable forces. Beyond their engineering value, these remarkable structures can transform remote locations into accessible destinations. In extreme environments, engineers must design structures to survive conditions far beyond ordinary construction limits. Before construction, engineers test structural models against simulated earthquakes to study how they respond to violent movement. Hydraulic systems and sensors recreate powerful seismic forces, revealing weaknesses before construction begins. Coastal structures must also withstand powerful storms, enormous waves, driving rain, and hurricane-force winds. Through careful design and testing, these structures can remain operational even after extreme natural events. But building these giants is only the beginning. Advanced sensors continuously monitor their structural health. Engineers regularly inspect critical connections, searching for cracks, corrosion, and signs of structural fatigue. Where humans cannot safely reach, robotic systems can inspect tunnels, walls, cables, and confined spaces. Specialized maintenance crews replace worn components, protect steel, and keep these massive structures operational. With continuous monitoring and maintenance, infrastructure designed decades ago can remain reliable for generations. These structures are not built simply to impress. They solve some of humanity's greatest transportation and energy challenges. Bridges, tunnels, and highways can connect isolated communities, reducing travel times and opening new opportunities. Modern transportation networks move millions of passengers, vehicles, and tons of cargo every single day. Dams and transmission networks generate and deliver electricity that powers cities, industries, and modern life. Together, these infrastructure systems become powerful economic engines, connecting factories, ports, cities, and markets. Behind every impossible structure is meticulous planning, precise calculations, and thousands of engineering decisions. From surveyors to welders and crane operators, thousands of workers must coordinate every stage of construction. At extreme heights and depths, safety becomes critical, demanding specialized equipment, training, and strict procedures.
Even a massive steel component must be positioned with extraordinary precision before it becomes part of the structure.
The greatest achievement is not conquering nature, but designing infrastructure that works within its forces. The next generation of mega projects is already changing how engineers imagine the future of construction. Autonomous machines, robotics, and advanced surveying systems are making complex construction faster and more precise. Future infrastructure could push even further, connecting distant regions through smarter and more resilient engineering. What once seemed impossible eventually becomes ordinary, quietly becoming part of everyday life around us. And perhaps the greatest lesson is simple. For human engineering, impossible may only mean not yet built.